Well, hello everyone. Welcome to part 2 of my coding tutorial. And in this series, I guess, we will be coding a group of projects in Visual Studio to do DLL injection into all running processes. So today we will start coding Windows device driver using C++ and kind of try to do some basic scaffolding. Now, before we begin, I want to point your attention to my friend here, Rbmm. Now make sure to check his page here and also his GitHub. And my solution and my code is actually based on his. He kindly provided me explanations of how he devised this plan of injecting DLL into all processes. And again, I am basing it on his code here. So make sure to check that. And without any further ado, let's kind of quickly review what we're doing here. So if we use Process Hacker and look at the processes that we have in our system, and at this point this is Windows 10 64-bit operating system, and well, let's just pick any process, and if we go and check modules, you will see a list of modules or DLLs that are currently loaded into this process. So our goal is to inject our own DLL, which we'll call FAKE.DLL, just for the lack of better name. So our goal is to inject that FAKE.DLL into every single process on the system, with the exception of native process, and that's the session manager right here. So if you look at it, it doesn't have many modules injected. Technically we can also inject into it, but there is a problem in the sense that it doesn't have, we won't be able to do much. We'll have to improvise all the system calls ourselves, pretty much like ntdll does. So I'll leave this to you if you want to kind of practice it yourself, or well, technically I can write it next time if you're curious, but it will just add a lot of unnecessary calls of me basically simulating what ntdll does to do system calls. So that's not very interesting, but pretty much any other process that is actual system process that runs in user mode, and I'm not talking about like the interrupts or whatever else that Process Hacker is showing, which technically is not a user mode process. But pretty much anything else here, including any protected and system processes, and including antivirus itself, we should be able to inject our DLL into it. Now, how would we do that? So if we go back to my really awful drawing here and look at it, I kind of tried to show you what, how DLLs or sections are shared in physical memory versus virtual memory. But to make this work, we will be using an internal API, which can be called from a driver, and this is this one, okay, with the long wonderful name of PS set load image notify routine. It will let us set a callback defined as such that will provide us a name of the module. In other words, every time one of these is injected or not injected, is mapped or loaded into a process, any process, this callback that we set up will be called in our driver. Well, the problem for us is how would we differentiate among many modules that are loaded? Because if we start mapping our fake DLL or fake injected DLL every time something else is mapped, that will greatly slow down the system. To avoid this, we can use the way Windows maps DLLs or modules into any user mode process. So for that, let me just quickly draw it out for you. Let's see if I can do it. Let's assume that we have, oops, I'm sorry guys, let me, yeah, I apologize. The pen here is something I just started using, so you'll see me fumbling with it quite a lot. Okay, so if we take process 3, with this really ugly outline, So the first thing that gets mapped, obviously it is its own PE file, right? But PE by itself would not be able to run because it won't be able to interact with system at all. So to make things more interesting, I mean not more interesting, but to make things functional, the next module that gets mapped is hang on one second, I'm just going to write it here, is ntdll.dll. This module is mapped pretty much into any user mode process. And this one is mapped next. So we'll just call it 1, because obviously the PE would be there anyway. So this module here is mapped into any user mode process, so you will see it there. Now the next one that is being mapped is what I showed on the left, and that is kernel 32, even though it's called kernel 32, and I'm sure Raymond Chan can explain why it's called that, but I really have no idea because it's not really a kernel module. But this DLL is mapped the second one. Now what is mapped next depends on the actual import modules that are in the process itself. But this is a guaranteed way that Windows maps any module. So first we get the process PE file itself, then we get ntdll, and then we get kernel DLL. Now we can technically trap ntdll in our callback, but the problem with that is that, well, obviously when ntdll is when our callback is called with ntdll, well, ntdll itself will not be yet resolved in the process. So we will not be able to resolve, we will not be able to rely on it. That's the word I was looking for. Thus, the best way or better way is to trap kernel 32. In this case, when we trap kernel 32 DLL, it will not be yet loaded into our process, but ntdll will be. So we should be able to rely on functions that are imported from ntdll, and then we can, technically, if we go with another color, we can inject our own module, our own FAKE.DLL into this process. And that's what we will do exactly from our callback. Now this obviously involves some additional steps, like, you know, writing FAKE.DLL in such a way that it can only rely on exports from ntdll.dll, which is kind of tricky. It means we can't use CRT. So if we kind of like quickly outline, we can say that no CRT, which is C runtime library, in our FAKE.DLL. And there's like additional restrictions and security things that we have to implement. Like, for instance, we have to have control flow guard enabled in our FAKE.DLL to be able to work, and some additional things. But we will deal with this a little bit later. But this is the kind of like basic outline of what we will be doing. And okay, so that's basically, you know, kind of like quick overview. There are additional things about the kernel programming itself, like what we can and cannot do. Like, for instance, because this callback is called from within a lock or a critical section, we won't be able to do much. So we will have to queue a kernel APC and do everything from the APC callback to actually do all of our stuff. Okay, well, that's enough talk, guys. So again, this is kind of like basic picture of what we will be doing. So let me get out from VM. Again, at this point, we will not need our VM. We don't have anything to test yet. So let's switch to our, well, let's say host or production machine, and let's start Visual Studio. And at this point, we need to create our solution. So let's create new project. And At this point, we need empty solution. Okay, blank solution, I guess. And for the lack of better name, I'm going to call it InjectAll. And I'm going to save it into my C++ folder. That's on my desktop. So at this point, it simply created blank solution. And what we need to do, now we will have several, we will have at least 2 projects in it. One will be our device driver, and the second one will be our DLL. Later on, we will add a simple module, kind of like user mode module, just to test our DLL. But for now, let's create our driver. So let's add, by the way, I'm in Solution Explorer in Visual Studio. Now I kind of rearranged the layout a little bit. I prefer for Solution Explorer and all windows to be on the left, so usually they are on the right, but I'm sure you can follow it. Let's see, we need add new project, and what I will be looking for is Windows, what is it called? Windows driver model, I think, WDM, and also empty project. Now I understand that WDM is kind of like old way of coding drivers, but in this case, like I said, I'm going with very low level stuff. Thus, I'm picking the lowest I can pick. And again, for the lack of better name, let's just call it DRV, I guess, for driver. And driver, by, all the drivers basically by convention usually use very simple names. That's just, I don't know, just happened to be like that. And here you go, we have empty project. Now what we will be using are 2 configurations, debug and release. This is very handy, so we will put a lot of debugging output in the debug, and obviously release will be our production code. And we don't need any ARM or ARM64, but we will need x64 and x86 configurations. I prefer to code everything in x86 to do all my debugging tests, because it kind of roots out all errors, but you can pick your own. Okay, well, at this point, let's add some files. So let's say new file, and let's just call C++, and we would call it, let's see, DrvMain. And we will put all of our main functions in here. Now let me increase the font a little bit for you guys so that you can see better. So we will be adding all the code here. Now I personally don't like putting all my code, even for drivers, even if I'm coding in like very simplified C++. And by the way, guys, we can't use any fancy C++ here. We can't even use constructors and destructors, because obviously we're coding a driver. Normally, you would use C to avoid any problems with, like, implicit stuff in C++, in modern C++. But I will kind of, I'm still missing certain functions of C++, so I won't be dealing with pure C. Instead, we will be kind of using C+, as I call it, so kind of like C++ without 1+. Okay? Well, let's do something else. Like, for instance, let's add special file. Let's see, add new, and this one will be H file, and here we will put all the driver types. Now, all the driver types, basically, we will put all the, let's just write it down, driver custom types and definitions. By the way, if you don't like me typing, this is a very long, it's going to be a very long video probably, so just scroll forward and then you'll see the actual fun stuff. So here we will be adding all the custom types, and also let's add all the libraries that we need. So we will need ntdll.dll. We will need min, oops, I guess it would help to put the right brackets. So min, let's say min win, let's see, where is it? SharedDef.h, and we also need some functions that would work with Windows images. I'm sorry, with NT images, ntImage.h, and we need some functions that would work with safe strings, and this is nt, not empty, nt string safe. Okay, so just kind of like basic folders, I mean basic includes. Let's make sure that we have our project configured. Now, okay, we have Windows kernel driver toolset set up, so that should be available for us. Okay, then we also need another file, which also would be H file, and this will be with shared definitions. Now, what is this thing? Well, shared definitions is a file that will be shared among several projects. Let's just say definitions that are shared across projects in this solution. I apologize. I personally can't even talk today, sorry. I personally like not hard coding certain things into like all source code files. I like to keep them in one file, so if something changes, then we should be able to just change it in one spot. Okay, and since I did that, we also need to include it in our driver types. Okay, and I also like to create several classes that we can actually use here. Let's see, new item, C++ class. Now one of them, let's call them CFunc, for the lack of better name. And yep, that's what I want, CFunc. Now, this will be very limited class, so we won't have much, much in here. It will be just helper functions, just so that we can put it in one spot, instead of like spreading it all over the main CPP class. So, and also we will need another class that we will probably create a little bit later. So in our CFunc.h, we need to include our driver types, and let's just say this is custom types. I will be adding comments like I would do in a production code. This is very helpful to actually be doing this because, well, if you are in the habit of not adding comments to your code, it will be, quite bad because, like when you just start not doing it, and then when you do need to add them, you just, you'll just forget, and it's just better to do it. Okay, well, let's see. Oh, we need to just let's see. Well, at this point, if we go into our driver main, we need to, let's say, main driver entry CPP file, for the lack of a better name. So we need to include our class, and let's just say helper functions, and we will be just calling them from here. Okay, now at this point we can create our driver entry. Now driver entry, I'm going to copy and paste it because it's a long typing thing. So what happens here is that driver entry is the code that is being called with these parameters. You can look it up in the actual WDM description in Microsoft Developer Network. And let's just call it main driver entry routine. Okay, and it has to return status. You know, for now, let's just return 0. And the reason I'm declaring it as extern C is because this function has to be declared as C function, so it's not C++ one. And because we're putting it into C++ file, we have to do it this way. Okay? Okay, so let's see, what else can we do? Well, let's try to build it. Obviously, it will create a lot of errors. Let's pull this out a little bit so we can see. Oh, well, we don't have SDK found, so that is a problem. So let's take a look. Okay, guys, this, if you look at the error code here, this is a good example when I don't have the correct Windows SDK. So if we go into Windows driver kit and into download, so if we look, we need 18.362, and I probably don't have it, so let's download it here and install it. So let me do this real quick and I will come back when it's all done. Okay, guys, I had to stop this recording and actually figure out what this error message means. They don't really make it easy. So if you go into control panel, the old one, and go into programs and features, what is important is that the version of your SDK, as you can see 19.041, matches the version of the Windows driver kit, and in this case it doesn't. So what I need to do, I need to install Windows driver kit to match this version, or this version, you know. So that's what I will do to actually make this error go away. I wish there was a better way for them to kind of like show all this stuff, because it's really confusing, but that's why it doesn't build. So again, let me pause it and I will quickly do it right now. And just to kind of walk you real quick, so if you go into your search engine and search for Windows driver kit, make sure to go to Microsoft website. And what I did, I downloaded the SDK version, and what I need to do now is download the DDK version. So kind of like redundant, a lot of downloading, so you have to run it. It will probably want you to uninstall the old one, but basically you see, like, you need this latest version, you need to download 1.8 gig, install it, and basically accept everything, blah blah blah, and half an hour later you will have your both SDK and DDK and WDK matching versions, and that's what that error was. So I'm gonna pause it and then come back when it's all done. Okay, guys, half an hour later, and downloading 2 gigabytes of something and installing and rebooting the system, I was able to kind of get a new error message. And basically Spectre-mitigated libraries are not present. I kind of like explained it in the preface in the first video, but let me do this again. Now the way to fix this Spectre thing, now for the driver we do need them. So if you go to let's see, Visual Studio Installer, so what you basically need, you need to go to Modify and wait for this thing to load, and go to Components. In the search, type in Spectre, and what you need to install the latest versions of it to match your driver kit. Now, just to do it with you, because it's very confusing, so if you get this error message, they will give you a link at the end. So if you control-click on it, it will open a web page that kind of describes all the stuff here. and you can read, you know, kind of like what it's doing. But basically you need to include these libraries. Now if we go back, let me just kind of scroll them a little bit. Not gonna show. Let's see if I can scroll them all the way here. So if we go into this huge list, now this is totally ridiculous how many of these they have. So we need Microsoft Visual C, and I have the latest one set up. Then Visual Studio C++ ATL. Let's see, we need the latest library. We have ATL and MFC. Just for the heck of it, because I do have them in case I have like an older library, I'm gonna do C++ here and ATL as well here. Now it really makes no sense to install ATL and MFC for driver, but heck, you know, this is Microsoft, so let's install it again, and when it's done I'll see if it builds. Okay guys, literally like an hour later I was able to get rid of that Spectre BS error. So just to show you, to save you some time, so what you need to do, you need to go into Visual Studio Installer, which is not in Control Panel, it's a separate app. And when you bring it up, you go into Modify. And again, if you installed any other components, now let me just show you just this idiocy. So if you just search for Spectre, you see how much BS is here. Now how is any reasonable person how would you even know which one to install? It just makes no sense. Like seriously, like all these versions, and anyway, just like horrible UI. So what you need to search for libs for Spectre, and important part is that you pick the latest one for your platform. In this case I'm doing for x64 or x86, and that's the only thing you need. Okay, so let me just kind of like scroll through stuff that I have here so you can actually match. Now this is a huge list, and like installing this Visual Studio is actually worse than installing SQL Server by how much BS you have to pick here just to be able to do anything like this stuff. Now why do we need like all those old selections? Can it be done automatically? But anyway, just ridiculous. Just literally wasted an hour installing this. I technically wouldn't blame you for disabling this whole Spectre thing, which you can do, by the way, over here if you go into Properties, let's see, C++, Code Generation, and just do Disable here. But, you know, for the driver, I wouldn't be doing it. But anyway, so let me just go through the whole list of what I have installed here. And somewhere in this huge list was that option that I showed you that you need to pick. Install. It will download a gigabyte of stuff, and I'm not kidding you, and then it will be good to go. So okay, I'm glad that I'm done with this, and I guess no one will return me my hour back. Okay, so then if you load everything up, reboot computer, blah blah blah, when you build you still have this error that tells you that device, basically driver, does not install. What it's saying is that the inf file does not have all the required information. Well, you don't really need it, so you can just delete it. And let's try building it again. And we have several problems here. Well, now the way you build driver is that you treat all warnings as errors, which is a good practice because, well, what happens is that warnings technically cause or may cause security vulnerabilities, and because we're building a driver, we need to make sure that, you know, all the warnings are taken care of. So in this case, we have these two parameters that are not used. So this is pretty easy to fix. There's a macro which is called unreferenced parameter. By the way, I love IntelliSense. You don't have to type all of it. So you specify it here and you specify it there. And also, guys, I forgot to do something. Because we are building two versions of the driver as x64 and x86, it would be nice to differentiate the executables themselves so that, you know, we can have two different versions. Now, we will be copying and pasting them from one VM to another. So when you have the actual bitness at the end, that would really help. So to change that, if we go into Properties, General, and what we need to change target name, in this case 64, because it's a 64-bit system, build, and for 32, we do 32, and let's do the same for release. Again, it's 32, and if we do x64, we do 64 here. And again, we will be testing all in debug configuration, so let's go back and build it. Okay, well, we got additional errors, so let's see what this means. So what happens here with this error is that Visual Studio attempts to sign your driver, and well, we have to run it as administrator basically to be able to do that, but we don't really need it to sign anything. So if we do into driver signing, and instead of test sign, we just do off and build it, well, it actually builds. So let's see if we got our executable here, and InjectAll, x64, debug, and here you go. So here's our little executable. If we load it into our program here with the WinAPI search, we can tell, but that doesn't have any exports or imports. So very simple executable, and we got it right here. So to make it build also on x64. Now the tricky thing about the driver is that we will have to test it in all 4 configurations. And we got the 32-bit build. Here you go. Now let's make a release build. Again, we're not going to be signing anything. Technically, you would do production signing here, but since we don't have a code signing certificate, we are not going to do that. So let's see here. Okay, we got our release driver, really small. And last one, we have to do x64. Also, let's remove test signing and build it. And we got, seems like we got 64-bit release driver also ready. Okay, so that is good news. So at this point, we have very simple driver that doesn't really do anything. It simply invokes our DriverEntry function and returns 0. So before we can actually test anything, let's create a simple debugging output function, and that will let us do some output into a debug view. And that way we can actually see if our driver is actually started and if we can do anything from it. So usually you would use DbgPrint or printx. I just use older DbgPrint. It's kind of like a printf type function where you just put stuff here, v equals, you know, specifier, and you put the actual value. But I personally like to customize it a little bit. Since we have our driver types file here, let's just add a little override, and I would call it DbgPrintLine. And what it will do, it will just add a new line at the end, add for the debug print, right? So and also, I would like to specify a debug prefix that all of our debug output would have. Now, the reason I'm doing this prefix thing is that basically it would have like some special name here, right? And what we do, we put this prefix here, and we provide our VA args there. Now, the way this works is that this special prefix will be added in front of our message. And the reason you would do that is because debug view will be outputting a lot of other information from other drivers. And this is just a nice way for us to kind of like say, hey, this is my driver, and we can filter only by it. So you can kind of like isolate the rest of the stuff. Now, to be more consistent, let's create a shared prefix for all projects. Let's see, define, and let's say dbg prefix all. And let's just put the name of our app, InjectAll _, and let's just say prefix to be added in all DbgPrint calls, right? So this little prefix thing. And then if we go back, so here we do this, and in this case we just say that this comes from a driver, and put space here, and again say prefix to be added in all DbgPrint calls in this project, right? And what we do here, we basically say, okay, this is our prefix, which again you can see is InjectAll, then _driver, so we can actually tell that this this output came from a driver. So now we can actually use this debug print to output some information. And what we will do, instead of just outputting this nonsense, we are going to say, well, let's say DriverUnload, and we would say, well, let's just say for completeness, we're going to use two parameters. Well, we're going to output driver object and registry path. So it will basically output that our DriverEntry function was executed, driver load. Then we would put that the driver object pointer, and then this parameter, which is Unicode string. Now, Unicode string is the struct that is used in kernel, and if you want to output it, you would do this kind of a specifier. Okay. Now, there is one other thing that we need to do to be good citizens for driver writers. We need to provide some routine to unload our driver, and what we do, we specify DriverUnload and provide that routine. I'm going to copy and paste it, and let's see, if I can type, routine that is called when driver is unloaded. Now, this is important so that we can unload our driver. And what we can do, we can also specify the same thing. Basically, we just say DriverUnload, and let's say, and then we provide a status, because you know when we are unloading driver, we will be actually doing some unloading here, so we will have nt status value. For now it's 0, and we are outputting the driver object so that we can compare it here to make sure that this is the same variable and our driver object. Okay, so at this point we have a minimum driver that really doesn't do anything. It loads and outputs this debugging string, and then when we unload it, it outputs this string. So let's change it to debug again and build it. Okay, so it builds all right. And at this point, let's try to run it. Now, the way you run your driver, well, first of all, let's find it. And again, this is kind of confusing. Make sure that you copy the right one. I personally always test debugger build and x64, so it will be in x64 debug. And here's the driver. So the way you test it, obviously you would not be testing it on the same host machine where you're coding it, because obviously that might cause a blue screen of death if you mess something up. And well, you can lose all your information, let alone you might actually lose the whole computer if you mess something up. So let's test it in a VM. Let's see if I can copy it across virtual machines here. And I can. So what I do, I create a special folder here on a drive C, and let's just call it InjectAll for the name of our product here. And let's copy it there. And we can actually test it right in this folder. Now guys, normally you would not be placing your driver into this kind of like, you know, makeup folder, and all the drivers would go into C, Windows, well, depending on the bitness, like 64-bit, System 32, and drivers. Now, because it's a long path and it will require elevation to actually place them here, just for simplicity, I will be putting my test driver into this very easy to find location. Okay, so let's try to run it. Now, to install it, we will use DriverLoader/Unloader. Let's run it as administrator. This is obviously important. And also important to remember your password when you started. So you can just drag into it. Okay, so here we go. Now, before we can run it, we actually need to see the output. Just move these things over. And to see the output, we need debug view. Also need to run as administrator. Make sure that the capture is set for all of it. And let's make sure that they both line up side by side. So we can technically register driver and start the driver. And, well, here's the problem. It doesn't have a digital signature. Okay, guys, yeah, this error basically happens because the driver file is not signed. And yeah, so we'll probably have to sign it in Visual Studio. So before we do anything, let's unregister it. And let's go back to our development machine. And we need to figure out how to sign it. Okay, guys, my bad. So basically, every driver that we are running, even with the test signing, has to be signed. So we technically, you know, I did this, but I shouldn't have done it. If we go into properties for the solution, driver signing general, we need to set it back to test signing. But the problem for me in this case, because I don't run, if I rebuild it, because I don't run Visual Studio elevated, it doesn't work. So what you need to do is basically start it elevated. And this way it will be able to sign. It's just, again, the way my system is configured here. So let's open it up again and go into properties, driver signing, test sign, okay. Then go into rebuild. It builds all right. Now I have to do this for all of them. Now I've done it already, turned it off, so now I have to turn it back on. Again, I apologize for this. Let's make sure that it all builds. It just adds this simple self-signed certificate for them so that we can actually run them on that system. And again, we shouldn't have done it originally, but that's how you learn, I guess. Okay, and this one, and we go into test sign and rebuild. Okay, nice. So all of them built. So let's go back to debug configuration x64. Let's rebuild it, make sure it works. Okay. So again, in our InjectAll x64 debug, and all we need is this driver64.sys. Let's copy it and paste it into our test VM. Okay, so let's pull it in here. Okay, so let's try to register driver. It registered, and start the driver. And here you go. We got our little driver load message here. And let's stop the driver. And we got driver unload. So this is exactly what we wanted, and we can unregister it. Now, just to give you a shortcut and how you can, work with this thing. Now, if you need to clear the output, you just do clear all. Also, as you can see, we have our special message here, InjectAll driver. So that's kind of like a prefix that we did, which is really helpful. So you can differentiate from other messages that, other Windows components will be outputting here. So to clear it, I usually do when I uninstall driver and I don't need old output. I just do this button here. Also, guys, to simplify this registration and starting, you can go into Actions, Register and Start, or press Ctrl-Shift-S, and that will do both things at once. Okay, and also when you unregister the driver, it stops it and then unregisters it. So if you click here, that's all done. Okay, so this is a little kind of like shortcut here, but this is how we will be testing our driver. Okay, so well, let's go back. And basically at this point we have a working driver, so we can actually start adding stuff into it. Now, this was very long and confusing video, so I will stop it for now and start next time from actually adding some helpful functionality into the driver, and hopefully I won't have to deal with installation and other kind of like BS that just wastes time. So guys, see you in the next video.